We talked before about costs. This is out of the Property Council of Australia's benchmarks for office buildings. If you take the proportion of electricity, which is HVAC, the proportion of building supervision, which is HVAC, gas and oil, which is a bit of an old term, and building automation, a number of other things, you end up with somewhere between 15 and 25% or even greater in terms of outgoings around HVAC. So some real costs associated with that. Whatever the number is, doesn't matter, it's increasing as a percentage and also as a real number. So costs are up there. It's worth looking at from a commercial perspective. To give you an idea of perhaps just some of the orders of magnitude of some of these costs, and in the property industry, we often focus on the short-term things. One of the really interesting transitions over the last couple of years has been perhaps the last 10 years has been the real dominance in the market of the big institutional owners. So you've got the GPTs and the Dexuses and people like that. They now take a long-term actuarial view of property, which we didn't have 15, 20 years ago. So they see things in a life cycle sense. But quite often on the ground, we do things in a year-by-year budgeting sense. And so it's hard to accommodate the fact that your chiller's worth $200,000 or $300,000 and you're simply walking past it every month and not looking after this bit of kit that's worth so much money and to some extent is relatively fragile properly. So there's some expensive bits of kit back in HVAC systems that really need to be looked after properly when you recognise the risks around them and obviously the capital replacement value. So a new HVAC system, and we talk about retrofits, nobody actually by and large completely replaces a HVAC system. That doesn't often happen. It does sometimes, but certainly in a new building, cost per square metre is around $450 to $750 a square metre. And again, the $750 relates to something like a 171 Collins and the $450 relates to something perhaps a little bit at the other end of the scale from that. Interesting to look at those chiller costs there. A large chiller can have $200,000 worth of refrigerant in it. You have a critical failure and you lose your refrigerant charge. Not only have you technically broken the law, you've effectively sent $200,000 out the window. Some pretty big risks around some of these sorts of things. When you come to look at plant like chillers, there are a whole series of regimes around it, which are obviously monthly but annual inspections. Also things like tuning systems. Again, it's not just about the maintenance, it's also about the duty they're put under. In a building that's not working well, and if you think back to the makeup I had before around the different components in the building, if you've got those 300 different rooms or zones in a building all calling for cooling at different times and the system not being very well organised and modulated, that chiller might start 500 times a day. The thing might have a 20 kilowatt motor on it. If you tune that particular building, the chiller might start twice a day. The net effect of doing that is that on a $200,000 or $300,000 piece of plant, you might put an extra 5 or even 10 years on its life. So again, a bigger number than what the energy would be that you would be saving, simply because you're actually not wearing your plant out because it's actually working properly. Again, something people don't talk about when they talk about tuning buildings, they talk about energy efficiency. But you actually, you think about the car analogy, you're driving down the road, you use your starter motor once a day when you start the car. If you're driving down the road and the starter motor is going off all the time, it'll wear out in a week. Same analogy. Things like refrigerant containment, refrigerant alarms are things that people are putting in to protect those big bits of kit and the risks around those big bits of kit in terms of refrigerant. Another observation around looking at replacing plant, because everything has a technical and a commercial life cycle. And quite often when you're getting to the end of both, it's hard to pick when to actually make a move. These days, new plant can come with 5-year extended warranties. From what you can see there with some of the numbers, it's clearly cheaper to maintain new plant because it's not as intensive, the thing doesn't break down as much. You haven't got to have the sort of repair budget you're talking about there. It's also interesting in those numbers up there to have a look at how much the essential services maintenance, if you like, just the compliant bit costs, compared with perhaps what you might do to properly maintain the building, which is one of the reasons why the more informed of you in the room, when you look at some of those rates, you'll say, well, geez, I'm not paying that much for my maintenance. That's pretty much probably because you're simply paying for a drive-by and a sign-off to say that I've actually attended to get compliance, but you're actually not looking after the kit. That's fine if you understand that, Nothing wrong with that at all. But understand it. Understand what you're getting for your money in a maintenance sense. Energy costs are an interesting thing. A little bit of a work up there in terms of typical electricity, gas and water costs per square metre in different buildings by way of energy efficiency. So probably once you talk about A's and B's, there's not a lot of 1.5 neighbour star buildings around, but there are a few. But the difference between a 1.5 neighbour star building and a 4.5 star neighbours building for about a 5,000 square metres building is around $70,000 a year. So if you do the maths on that, that tells you if you're working on, say, a 7-year payback, and some people work on that, some people work on shorter, but you work that back and it tells you you've got about $100 a square metre to spend to get a return on energy savings. So there's some basic, I suppose, maths around all that. A couple of points around energy efficiency, again, which we'll touch upon next week. Energy efficiency always comes with benefits. You just don't improve energy efficiency and see your energy bill shrink. You always end up with benefits. You end up with a system which is more reliable. You end up with tenants who are happier. You end up with a system which will last longer. These things always come out of works to make HVAC systems more energy efficiency. The best way to do energy efficiency is not to do energy efficiency in its own right. The best way to do it is actually to work out, well, I'm doing a half-life refit, I'm replacing this bit of kit, or the chiller's worn out. As part of that process, I will make sure I get an energy efficiency outcome as well. So effectively, when you're doing a cost-benefit, the benefits are around not just energy, but a whole range of other things as well. Decreased maintenance costs, increased plant life, building positioning, a whole range of different things. Anyway, more about that next week. Just in terms of where energy is all going, it's all a bit interesting at the moment. If I'd stood up here 2 years ago, I'd be saying things around, well, electricity is going to keep going through the roof, we're all going to die. Really interesting phenomenon in the last probably 12 months. We've recognised that the country's electricity demand is actually reducing. The amount of energy we're using, per square metre, per person, per process is actually reducing. And it's not just reducing a little bit, it's reducing quite significantly. So whether it be solar PV, which has had a measurable effect, whether it be energy efficiency, whether it be the commercial reality around energy costing more so we'll use less, that non-elasticity view, it's actually, the demand's going down. The strange phenomenon, though, is that in response to the predictions of energy usage going through the roof 4 or 5 years ago, the electricity distribution industry in the last few years has spent billions of dollars on making their poles and wires bigger, if you like. And now we're all paying for that investment that they don't need. So some interesting phenomena around electricity prices. Sure, there's also different ways to cut electricity prices. What you pay at home isn't what you or your employer will pay at work. There's some absolute cracker deals out there because it's a commercial market as such. There's a lot of energy efficiency kit installed in some pretty swoopy buildings around town that actually doesn't get used because they got a great electricity deal, and so why should they run it? Interesting things around all that. A lot of the modelling had carbon tax in it. Apparently we're getting rid of the carbon tax. What effect will that have? Gas is an interesting question in itself. Some of you may have read in the paper the escalation around gas prices, which I'll talk to in a moment. That has an effect on electricity prices around the country because we do use gas to generate electricity, not just good old brown coal as we do in Victoria. The drought had an interesting effect on electricity prices. That put a real spike in electricity prices because power stations require water to cool them. So the next drought will see the power of energy go up again. So all sorts of interesting things. So yes, electricity prices will continue to escalate. I think the graphs that show that might not be the case, must admit, I've never seen that ever really happen. Things do keep going up one way or the other. But it's going to flatten out. It's certainly not going to be the rate we've seen in the last couple of years in terms of electricity costs, which in some ways for the energy efficiency industry is not probably good news. Gas is a different story entirely. We're in the process of building 3 or 4 major gas trains in Queensland to take gas out of the ground and put it in large ships and sell it overseas. Those gas trains are hooked back to effectively what is a national gas grid. And so we're heading towards paying international parity price for gas. And that's driving the cost of gas absolutely skyward. And so that graph on the right-hand side, there's predictions that we might see escalation in terms of gas prices somewhere north of 30% over the next 3 to 4 years. Now, from a buildings perspective, gas is not a major energy input, electricity is. But obviously some of our industries, whether it be food or manufacturing, heavily depends upon gas and the price of gas. So again, that's why you're starting to see some real angst in the papers around what we've done in a policy sense around that gas pricing. In a building sense, you might have noticed that there's not a lot of noise around cogen and trigen systems anymore in buildings. It's really gone off the boil. In some ways, it's pretty much killed the whole idea of cogen and trigen in commercial buildings. The gas price has just made it not economically viable in many, many cases. There's still situations where it works, but it's really, really changed the nature of that commercial idea.